Hello, good evening, my friends and followers. Welcome to my channel. In this series of navigation lecture, I will be covering today the very important topic, that is convergency as well as the conversion angle. Let us see first of all what convergency does it means, what is the implication of the convergency, and how it helps in the navigation. Gentlemen, you already know about the earth, and in my previous class I have already told you regarding the latitude as well as the longitudes. The longitudes are also called as the meridians. Let us take two meridian here. If we see this meridian, which is marked by the green line, from which is connecting from North Pole to South Pole, you will see that the the longitude, they start from the North Pole, and as it goes down towards the equator, you see that it keeps on diverging, and thereafter at the equator it is at maximum displacement. Thereafter, when once it goes down to the South Pole, again it starts converging and they intersect or converge together at the South Pole. Means to say that both at the North Pole as well as at the South Pole, they make an angle. Now, what is the implication of this angle? What is the importance of this angle? Let us understand. If we take one of the longitude or meridian as the prime meridian, and the another meridian as M1, and suppose this meridian is 60 degree east of prime meridian. Obviously the directions when we measure from prime meridian towards the easterly direction, they are at east, and towards the westerly it is towards the west. So therefore, if we assume that this meridian is 60 degree east of prime meridian, then here we can write down as 60 degree east. Now, this meridian is at the equator 60 degree east of prime meridian. It is the same 60 degree east if we take a particular latitude at L1, let's say, or L2 or L3. The 60 degree east will remain same. Till North Pole. Means to say that is why they make at the North Pole or at the South Pole a 60 degree. Am I correct? So it means that this angle becomes 60 degree, and the same 60 degrees towards the south also. It means the angle between two meridians at North Pole or at the South Pole is called as convergence. And the meridians, when they intersect at North Pole as well as the South Pole, they make an angle. This angle is called as convergence. The degree which they make at the latitude, at any particular latitude, is called as change of longitude. That is called as change of longitude. So it means that this change of longitude 60 degrees is also the change of longitude at the North Pole or at the South Pole. Means to say that here we can write that the convergency is equal to change of longitude. Very important. Now you have to understand, if I write convergency is equal to change of longitude, does it holds for all the latitude? Does for all the latitude it remains the same? This equation holds? No, it's not so. Let us see why is it not so. If we take at here, you can see this is the your Earth. The same two meridians I have taken. This is your equator, and these are the latitudes. As I have assumed the latitude as L1, L2, L3, and L4, and the last one is your equator. Obviously, this is your North Pole. Now, if we take these 2 points at the latitude where both the meridians are intersecting, you will find that if you take this position as A and this position as B, and you draw a tangent over point A and as well as point B, they are going to meet at North Pole. Means to say that the angle which they subtend is 60 degree if the change of longitude here is 60 degree. Obviously, but the change of longitude here is 60 degree, but the distance varies. The distance is more because the meridians are diverging as it is going towards equator. So for that, if I take as C and D points, and if I draw 2 tangents over C as well as on D, these tangents are not going to meet at North Pole. These tangents are going to meet somewhere at the position as indicated here, or you can take as PL2, P2. Let us assume to be P2. So this, if you draw the tangent at point C as well as D, they both of them intersect at a point which is farther from the North Pole, and they subtend an angle of L2, or you can also call it as Lima or Alpha 2 at the position P2. Similarly, if you draw 2 tangents at E and F at the latitude L3, they both will intersect at Alpha 3, intersect and make an angle of L3 or Alpha 3, or you can also call this as P3. And similarly for latitude 4, the angle which is subtended L4. And if you draw the tangent at the equator, they are never going to meet at any particular point, as if you draw the tangents, they are the parallel lines and they will never meet. So therefore, the convergency at the equator is 0, because both these lines are parallels and they are not going to meet at any place. So therefore, the convergency, or they never meet, so it is equal to 0. However, if you see here, the latitude as higher or at the poles, it is subtending at 60 degree. Means to say that the convergency at pole is equal to 60 degree, whereas convergency at equator is equal to 0 degree. So depending upon the latitude, your convergency is changing. Hence, we can change this formula in order to generalize this for entire latitudes which they are covering. So therefore, we can write down as now convergency is equal to change of longitude into sine of latitude. Why sine? Because if you put sine 60 degree, it will give you some value at the pole, which is the maximum value of 60 degree. And if you're putting a sine 0 degree, So therefore sine 0 is equal to 0. So that is why at the equator it is 0. So my equation holds. Putting sine as a latitude, this equation holds for entire latitudes, come what may, for all the meridians. Now, having seen about this, that convergency is equal to change of longitude into sine of latitude. Now again, there is something which is still lacking behind. Now what is that? If you see this diagram, here the points which were A, B, C, D, E, F, these points were taken over latitudes, one specific latitude. But when we fly from one place to another, we are not going to fly along latitude always. Can it be so? It cannot be. So therefore, we have to fly from one place to another. It might be that we will be intersecting any latitude. So therefore, again, my formula has to be generalized to give you more generalized form if we are flying from one place to another, cutting 2 to 3 latitudes. So let us say in that scenario, so therefore now my equation is convergency is equal to change of longitude into sine of latitude. I am going to make this formula more generic for all the latitudes, even if you fly and crisscross from one latitude to another. That is to say, if we are crossing, if my point is here and we are flying from here to point B, which is in another latitude, then what will happen? Obviously, as we have already seen there, that it is the distance between the latitude which is varying, and because of that the angle is varying. Now here the distance which is here, it is crossing the 2 or 3 latitudes. Means to say that if we have to take an angle which is subtending, will be more generic form, and for that the calculations will be, first of all we have to take a very small portion of that latitude, and then we have to calculate the angle. Thereafter then we have to do the integration for the entire of the latitudes, or entire of the distance which we are going to cover. It is very, very complex and difficult, and it is out of the scope. So what do we do? And even if we calculate that integration, the answer which comes is very, very similar if we take the distance, a mean distance to that particular. That is to say that we take this latitude C and D, CD, as well as we take this latitude which is at G and H, you can say, and we take the mean of these two latitude. That is to, at some position this will come, and thereafter this will give you the angle which they subtends. That is to say that the convergency is equal to change of longitude into sine of latitude. It is because for the one particular specific latitude, but here we are talking about a number of latitude. So therefore the first latitude and the last terminal point latitude. So therefore we have to take the mean of both the latitudes. Therefore the formula now becomes is convergency is equal to change of longitude into sine of mean of latitudes. So here we take this latitude from where this point from where we are originating, we are starting off, we are taking off, and the point, the terminal point. So this terminal point is on this latitude. This is the starting point on this latitude. And if we take both the latitude, mean of them, somewhere that will give you the latitude in the midway, and the angle which is subtended will give you sine mean latitude value. Here in this formula we have catered first of all the angle, thereafter we have catered for the latitude, a particular latitude, and further we have generalized to taking into whenever we are flying from one place to another, crossing in any particular latitude. Here I finish off the convergency is equal to change of longitude into sine mean lat. I hope I could have made you understand about the basic concept of convergency. In continuation to this part, let us see what does now the conversion angle means. Gentlemen, a conversion angle, before coming to that, we will first of all generalize this, and thereafter then we will see what does that conversion angle means. Prior to that, we have to see what does there are various type of projections in the navigation which takes the help of this convergency. Which all projections are there in the navigation? Can anybody tell me? Okay, coming prior to that, first of all, we'll first